Hello out there, welcome to this tutorial on inequalities. In this video, we'll be looking at absolute values. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on inequalities. So we start with definition. The absolute value of a number x denoted by modulus of x is defined as the modulus of x is equal to x if x is greater than 0 and negative x if x is less than 0. On a normal good day, the absolute value of a number is returning the positive values of the number. So we look at some basic facts about absolute values. 1. If absolute value of x is less than n, then negative n less than x less than n. 2. If absolute value of x is greater than n, then x is greater than n or x is less than negative n. 3. If absolute value of x plus or minus m is less than n, then negative n is less than x plus or minus m less than n. 4. If absolute value of x plus or minus m is greater than n, then x plus or minus m is greater than n or x plus or minus m is less than negative n. 5. If absolute value of x plus or minus m is less than absolute value of x plus or minus n, then x plus or minus m all squared is less than x plus or minus n all squared. And lastly, if absolute value of x plus or minus m is greater than absolute value of x plus or minus n, then x plus or minus m all squared is greater than x plus or minus n all squared. These are the facts we are going to explore in solving problems in this video. So we start with the first problem. Problem 1. Find the range of values of x for each of the following and show your result on a number line. We have problems A and B. So we start with A part of the problem. We have stated earlier we are going to explore the basic facts of absolute values to solve the problems. So we go. If modulus of x is less than 6, then negative 6 is less than x less than 6. So we are done with the solution to the absolute value of x less than 6. We then plot it on the number line. So we have 0 here, 6 and negative 6. Since it is from negative 6 to 6, so we mark the negative 6 to positive 6. We join, and that is the range of values of x. So that is it. Then alternatively, we can employ the other fact of squaring both sides, so that we now have x squared is less than 36, forming quadratic inequality. From here we have x squared minus 36 less than 0. This is difference of two squares, so we have x plus 6 into x minus 6 less than 0. We have two approaches, even three, of resolving this problem. We have the analytical method, and we have either the graphical method or using the number line. We have used the graphical method in our previous video on quadratic inequalities. So this we are going to employ the number line. So if you solve this, we are going to have negative 6 and positive 6. So we have it as 0, 6 and negative 6. So in this number line, we have three regions. So the first one, which is x is greater than 6, is from 6 to the right. The second one, which is negative 6 to the left, and that represents x is less than negative 6. And the third region is between negative 6 and 6. That's going to give us negative 6 less than x less than 6. So we are going to go by inspection to pick value from each of the regions, substitute into the inequality, and get their positive value or negative value. Then we are only interested, is it positive or negative? So we pick from 6 to the right, and the value we are picking there is 7. You can pick any other value, so it depends on how convenient it is for you. So 7 plus 6 gives 13. 7 minus 6 gives 1. So 13 times 1 is 13, and that is positive. So that region is positive. Then from negative 6 to 6, we pick any value again, which is 0. This is going to give us 6 times negative 6 will give us negative 36. So the value there is negative. Then from negative 6 to the left, we are picking negative 7. So negative 7 plus 6 gives negative 1. Negative 7 minus 6 gives negative 13. So negative 1 times negative 13 gives positive 13. So this region, again, we have positive. So if you look at our inequality symbol, this is less than 0, which means it is a negative value. So the product of this and this will give us negative. So at that point, this is the region representing the solution of this inequality, which is going to give us negative 6 less than x less than 6. So that is the alternative method of solving this absolute inequality in problem 1a. The number line is still the same as in the first method, so we have it there. Then we now go to B part of the problem. For B, we have absolute value of x greater than or equal to 3. We say if absolute value of x is greater than or equal to 3, then x is greater than or equal to 3, or x is less than or equal to negative 3. And that is done. So the next thing now is to show the results on a number line. So we have the number line. This is 0, 3, and negative 3. From here, x is greater than or equal to 3. We go to the number line where x is 3. We mark it with circle. Since it is greater than or equal to, we are going to shade it. Then the arrow is going to the right, and that is the range of values of x there. Then to the other one, x is less than or equal to negative 3. We go to where x is negative 3 on the number line, mark it. Since it is less than or equal to, we shade, and the arrow is going to the left. That is the other range of values of x. It is the union of x is greater than or equal to 3 and x is less than or equal to negative 3 that will give the solution of the problem represented in 1b. Then alternatively, we said we are going to square both sides. That's going to give us x squared greater than or equal to 9. Forming quadratic inequality from here, we have x squared minus 9 greater than or equal to 0. From here, we factorize, since this is difference of two squares. X plus 3 into x minus 3 is greater than or equal to 0. Then we go by inspection from a number line. This is 0, 3, negative 1. Remember, we have 3 regions, and each of the regions is representing a range of values of x. The first region is 3 to the right, which is x is greater than 3. The other one is between negative 3 and 3, which is negative 3 less than x less than 3. And the third region is from negative 3 to the left, which is x is less than negative 3. So we are going to get a value from each of the regions, substitute into the inequality, get the sign, use it to get the range of values of x, which represent the solution of problem 1b. So starting from this region, x is greater than or equal to 3. So we have 4 there. So if you pick 4, 4 plus 3 gives 7. 4 minus 3 gives 1. So 7 times 1 gives 7. So it is positive at that region. Then within this region, we are picking x is 0. So this is 0 plus 3, 0 minus 3. So that's going to give us 3 times negative 3, which gives negative 9. So within this region, the inequality is negative. And to the left of negative 3, we pick negative 4. Negative 4 plus 3 gives negative 1. Negative 4 minus 3 gives negative 7. So negative 1 times negative 7 gives positive 7. So in this region again, we are having it as positive. So from here, we can expect to get the range of values of x. Here, the inequality symbol is greater than or equal to 0. So greater than 0 is a positive value. So what we do is we pick the side that is positive. So which means x is greater than or equal to 3, or x is less than or equal to negative 3. So the number line is still the same with the first method. So we have 0, 3, this is it going to this side, and here this is going to this side, and we have our x there. So we are done with problem 1. We then go to problem 2. For problem 2, find the range of values of x satisfying each of the following. So we have 2 problems there. We then start with A. Still exploring the basic fact about absolute inequalities. We want to look at both method as used in problem 1. Starting with the first method, if absolute value of x minus 2 is less than or equal to 5, then negative 5 less than or equal to x minus 2 less than or equal to 5. We are going to create 2 inequalities from here. Remember to check the description section of this video on our YouTube channel to get the link to the playlist containing combining inequalities, where we treated something like this. So we first inequality we are creating is from -5 to -2 here, just before the second inequality. So we create the inequality from there, we solve. So taking this to this side, we have -5 plus 2 less than or equal to x, where -3 is less than or equal to x. We are going to keep this, we create the second one, which is going to be exactly after the first inequality up till the end. We also solve. In our solution, we take this -2 to the right hand side. I have x is less than or equal to 5 plus 2, where x is less than or equal to 7. Then this is the second inequality we are going to combine. So we combined them as -3 less than or equal to x, and that same x is less than or equal to 7. And that's all for the first method. Then the alternative method is to square both sides. That's going to give us x minus 2 all squared less than or equal to 25. So we expand the left hand side, which gives x squared minus 4x plus 4 less than or equal to 25. So forming the quadratic inequality from here, x squared minus 4x minus 21 is less than or equal to 0. For your information, we have treated this quadratic inequality using graphical method in our previous video. Remember to check the description section of this video on our YouTube channel to get the link to the playlist containing the said quadratic inequality. But we are going to use a different approach here. So first we factorize. So the factors are x plus 3 into x minus 7 less than or equal to 0. We mark it as asterisk. Then we bring in our number line. This is 0, 7 and negative 3. So we said we have three range of values of x. The first one being x less than or equal to 3. This is to the left. The second one being x greater than or equal to 7. That is 7 to the right. And the closed interval here, which is negative 3 less than or equal to x less than or equal to 7. Then we pick the first range of values, which is x less than or equal to negative 3. Pick a value there. We pick x is equal to negative 4. Substitute it here. If you substitute, we are going to have minus 1 times minus 11, which is giving us plus 11. The whole of this inequality will give us 11 when x is negative 4, and this is greater than 0. And our inequality symbol here is less than or equal to 0, so this is not going to be a solution. Then for x greater than or equal to 7, we are picking x is equal to 8. This is 11 times 1, which is still giving us 11, and it's greater than 0. It's not going to be part of our solution also. And for negative 3 less than or equal to x less than or equal to 7, we are picking x is equal to 0 there. Putting this, we are going to have negative 21, and this is less than 0, and our inequality symbol is less than 0. That is forming our solution, so that we have our solution as negative 3 less than or equal to x less than or equal to 7. And these are the two methods of solving this particular problem. For your information, I don't know the curriculum you are operating. You might not be required to use a particular method. Just choose the one that is easier for you. So we go to B part of the problem. For B, we have an absolute value on the left hand side mixed with non-absolute value number, and we have the non-absolute value number at the right. So we collect the like terms. So we now have 2x plus 1 on the left hand side. Taking this to the other side, it becomes 7 minus 2, which is greater than 5. So we now apply the first approach. So if absolute value of 2x plus 1 is greater than 5, then 2x plus 1 is greater than 5, or 2x plus 1 is less than negative 5. So from here, we solve the individual inequalities and combine. So we have 2x is greater than 4, where x is greater than 2, or 2x is less than negative 6. If you take this to the right hand side, it becomes negative 1, where x is less than negative 3. And that is all. So with this, we have the range of values of x which satisfy the inequality in B. Then we can go ahead for the alternative method, where we are going to square both sides. We start from here. That's going to give us 2x plus 1 squared is greater than 25. So that we now have 4x squared plus 4x plus 1 is greater than 25. Forming the quadratic inequality from here, 4x squared plus 4x minus 24 is greater than 0. Remember, we can divide through by 4. So we have x squared plus x minus 6 is greater than 0. So we factorize. That's giving us x plus 3 into x minus 2 greater than 0. So we mark it asterisk. So from our number line, here I have intentionally omitted the 0. That is to tell you it might not be compulsory. So we have three range of values from here. We have the first one being x less than -3, that is from -3 to the left hand side, x greater than 2 from 2 to the right hand side, and the middle interval here, which is -3 less than x less than 2. We pick value from each of these range of values and substitute into our inequality to determine our solution. We are picking x is equal to -4. Putting x is -4. We have -1, -6, and that's going to give us a +6 and is greater than 0. So that's going to form our solution. Then for x greater than 2, we are picking x to be equal to 3 there. This is 6 times 1, and that will give us a 6, which is still greater than 0, still forming our solution. Here we are picking x is equal to 0. This is 3 times -2, giving us -6. That's giving us less than 0. This is not going to form our solution. So with this, we conclude our solution is x is less than -3 or x is greater than 2, which gives the range of values of x satisfying the inequality represented in 2b. And that's the end of solution to problem 2. We go to problem 3. So for problem 3, find the values of x which satisfy each of the following. So we have to find the values of x which satisfy each of the following. So starting from A, if you look at this is different from the first two problems we solved. In problem 3 here, we have the absolute value on both sides. So what we are going to do, there's only one approach for now. We are going to apply the principle of squaring both sides. So we said if absolute value of x minus 5 is less than absolute value of x, then x minus 5 squared less than x squared. So we expand, this giving us x squared minus 10x plus 25 is less than x squared. Remember, if you take this to the other side, it will vanish. So we are going to have minus 10x plus 25 less than 0. So we take this to this side, it becomes minus 10x is less than -25. Since we are dividing both sides by -10, x is now greater than 2.5. Remember, if you are dividing both sides of any inequality by negative, the sign changes. So that is all for problem 3a. We go to 3b. For 3b again, if absolute value of 2x minus 3 is greater than absolute value of 2x plus 3, then 2x minus 3 squared is greater than or equal to 2x plus 3 squared. So expanding this, I have 4x squared minus 12x plus 9 is greater than or equal to 4x squared plus 12x plus 9. So again, this one will cancel this, since 4x squared minus 4x squared gives 0. Also, 9 going to this side we cancel, so we are now left with negative 12x greater than or equal to 12x. We bring this to this side, it becomes negative 24x is greater than or equal to 0. Dividing both sides by negative number again, we have x is less than or equal to 0. And that is all for problem 3. We then go to problem 4. For problem 4, find the values of x which satisfy each of the following. In problem 4, we have the two sides of the inequality inside absolute value except the 3 here, which is still the same thing as putting it inside, because in the solution starting from A, we are still going to square both sides if absolute value of 3x plus 2 is less than 3 absolute value of x. Then we have 3x plus 2 all squared less than 3x all squared. So expanding this, I have 9x squared plus 12x plus 4 less than 9x squared. Remember, this 9x squared, we go with 9x squared. We'll be left with 0 at the right hand side. So I have 12x plus 4 less than 0. Taking this to the right hand side, I have 12x less than negative 4. Then dividing both sides by 12, x is less than negative 1 over 3. So that's all for problem 4a. We then go to 4b. For 4b, the same way, it is possible to use these two to multiply everything inside the absolute value before squaring. But still, you are going to have the same answer with our approach of not expanding it before squaring. So if absolute value of 2x minus 1 is greater than 2 into absolute value of x plus 2, then 2x minus 1 squared is going to be greater than or equal to square of 2 into x plus 2. So expanding this, I have 4x squared minus 4x plus 1 greater than or equal to squaring these two, we have 4. Then expanding this, I have x squared plus 4x plus 4. And then we now expand this again, giving us 4x squared minus 4x plus 1 greater than or equal to 4x squared plus 16x plus 16. Remember, this 4x squared, we cancel 4x squared. So then we then collect the like terms. Negative 4x minus 16x greater than or equal to 16 minus 1. This positive 1 going to the right hand side of the inequality changes to negative 1. This is giving us negative 20x greater than 15. Since we are dividing both sides by negative 20, x is less than or equal to negative 3 over 4. And that is the end of solution to this problem. And this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Remember to subscribe to our YouTube channel, Uninab Resources. Don't forget to check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on inequalities. Until we come your way again, goodbye.